Let's discuss one more useful technique that we can carry out using the dummy variables. This is called piecewise linear regression. To understand this, look at this example. We have a hypothetical company which compensates its sales representatives based on the sales that they manage to execute. So the commission based for the sales follow a certain formula till you reach a target or threshold level called X star. Beyond X star, that is, if the sales reported successfully by the salesman exceeds this threshold level of X star, the commission structure undergoes a very definite change. Okay, so that's a hypothetical company which has a certain pattern for awarding compensation till X star, and beyond X star, the pattern of compensation totally changes. When you have such a case, you have what is called a piecewise linear regression. This is because your regression function consists of two linear pieces or two linear segments. The figure over here shows the two linear segments. So segment 1 is the standard commission, sales commission function till you reach the threshold level X star. Generally, X star is known to you a priori or in advance. This is also known, this threshold level of sales is also known as a knot. Okay, and beyond this X star, your pattern of compensation takes a total different change, and it is represented by the second segment of straight line labeled Roman number 2. What is the regression that you will have to run for estimating such a piecewise linear regression? It will be yi is equal to alpha 1, which is our intercept term, plus beta 1 xi, where xi is the volume of sales generated by a salesperson, right? Plus beta 2 times xi minus x star times di. This is where the dummy variable comes in. The dummy variable is equal to 1 if your sales volume xi is greater than threshold level X star. And if the sales value is less than X star, the dummy variable takes the value 0. So if you take the mean sales commission, alpha 1 plus beta 1 xi will be your mean sales commission as long as your sales is less than target level or threshold level X star. Once the sales generated, the volume of sales exceeds the threshold level, your mean sales commission will be alpha 1 plus beta 1 xi plus beta 2 xi minus x star. Once it has exceeded, your sales volume has exceeded X star, remember your dummy will take the value of 1. So you have a third term, beta 2 times xi minus x star. Now that can be simplified and written as alpha 1 minus beta 2 times x star. So this is your difference in intercept term. Remember, x star is fixed. It is known to you in advance and it is fixed, so it is not a variable. And the difference in slope will be beta 1 plus beta 2 times xi. You have got this final equation by just rearranging alpha 1 plus beta 1 xi plus beta 2 times xi minus x bar. So as you can see, the second component in the figure, that is the second line segment, the difference in intercept is given by alpha 1 minus beta 2 x star, and the difference in slope will be given by beta 1 plus beta 2. Right? This is the differential slope. Once again, whether there is a change in only the intercept or in the intercept as well as the slope or just the slope can be determined by testing the significance level of beta 2, which is the coefficient that appears along with the dummy variable. So in this case, if beta 2 is significant, both intercept and slope will be different, right? So these are just different uses of dummy variable technique. These are very useful for you because all the project and dissertation topics that you are going to do in your 4th semester, the dummy variable plays a very important role in that. If you're trying to estimate the effect of, say, discrimination on the labor market wages, that is my favorite example, you can try and calculate observation or collect observations regarding the mean wages, and you can see whether it is different for men and women for the same work. You can see whether it's different for different groups of people like SC, ST, OBC and so on. You can see if it is different for people from different places of origin. So in the context of Kerala, you can see whether the average or mean wages are different for Malayalis and different for those who are coming from the Orissa, West Bengal, Bihar belt, So there are lots of such possible project topics that you can think of. And in all these places where you have qualitative variables, the dummy variable technique comes to your rescue. So please do go through the chapter number 9 of Damodar Gujarati and get back to me if you have any doubts. It's a very useful technique, and I'm sure many of you will be able to use this in your upcoming dissertation. I will just conclude by telling you that the piecewise linear regression that we discussed in this example is a member of the more general class of functions known as spline functions. Okay, of course, the higher order spline functions are outside your syllabus, so we are not going to discuss that. Just remember that the model that we just discussed now belongs to the category of spline functions. Okay. Now, as a concluding slide, I'm going to show you this. We have so far discussed situations where the x variables might be qualitative, right? So you might have race, gender, caste, or region of residence, or so many other level of education, and so many other categorical and qualitative variables which enter as your explanatory variable in the regression. But often we might come across a situation where your dependent variable, that is y variable itself, is a qualitative variable. Can you think of examples? Yeah, I have mentioned 2 over here. Your decision whether to enter the labor force or not, it is influenced by several factors. It is influenced by your level of education, your current level of say wealth or income, maybe family income. So if you are belonging to a very poor family, the pressing needs for money might force you to enter the labor force at an earlier age. So it will also depend on what age you are. It will depend on what your level of education is. If you're still in the process of studying or pursuing higher studies, maybe you are not ready to enter the labor force yet. But in all these cases, your main y variable is whether to enter the labor force or not. So it is a dichotomous variable. Dichotomous means it has only 2 options, where one represents entering the labor force, and 2 represents not entering the labor force, right? You can think of categorical variable which has more than 2 possibilities. So your choice of transportation from college, from home to college, whether you want to travel by bus, whether you want to travel by a car, or whether you want to travel by an auto rickshaw. Now, what affects this decision? Your income levels would be a good explanatory variable. Whether you're male or female could have an influence on the mode of travel that you choose. Whether you stay far away from college or very close by, that could be a determining factor. So maybe distance to college or distance of travel is an important explanatory variable. But in all these cases, as you can see, the y variable here is a categorical variable, where bus or car or auto rickshaw is the possible choice or possible value that the y variable will take. Okay, so in these examples, when your y variable is a categorical variable, can you apply the OLS method, the regular OLS criteria for estimating the regression model? Well, there's nothing stopping you. If you put in such data into your SPSS or any other statistical package, the regression mechanically gets run and you will get an output sheet based on the data that you have entered. However, you will notice that when your y variable is a categorical variable, the data that you have, it will be full of statistical problems. Not all of your OLS assumptions will be satisfied completely, and that will give rise to problems when it comes to hypothesis testing and making inferences. So whenever your dependent variable becomes a dummy variable, you will have to let go of the OLS technique and you will have to go for logit or probit models. These are 2 models that we'll be discussing in the next module. So these are the only 2 options, and they are also quite useful and interesting techniques, having a lot of practical implications for your dissertations. Okay, so please do pay attention to logit and probit models. You might find them useful in the next few classes.